Download this code from codegive.com, link in the description below. Accessing the file manager on iOS, iPhone, with code, a comprehensive guide. Directly accessing and manipulating the entire file system on iOS, like you might on a desktop operating system, is severely restricted due to Apple's security model, sandboxing. However, you can interact with files and directories within your app's sandbox, which provides a secure and isolated environment for your application's data. This tutorial will explore 1. Understanding iOS sandboxing *, why you can't just browse the entire file system. 2. Accessing your app's sandbox *, the directories you can access. 3. Using filemanager *, the primary API for file and directory manipulation. 4. Reading and writing files *, basic file operations. 5. Creating and deleting directories *, managing your app's folder structure. 6. Listing directory contents *, getting a list of files and subdirectories. 7. Moving and copying files *, relocating files within your sandbox. 8. URL schemes for opening files in other apps, limited how to indirectly interact with files managed by other apps. 9. Document providers / pickers, UI document picker view controller, another indirect way to interact with files outside your sandbox. 10. iCloud Drive integration, UI document browser view controller accessing and managing files in iCloud. 11. Code examples in Swift * practical examples to illustrate each concept. 12. Error handling * robustly managing potential issues. 13. Security considerations * best practices to protect your app's data. 1. Understanding iOS sandboxing. iOS apps operate within a security sandbox. This sandbox is a restricted environment that limits the app's access to system resources and data. The primary goals of sandboxing are security * preventing malicious apps from accessing sensitive system data or interfering with other apps. Stability * ensuring that one app cannot crash the entire system. Privacy * protecting user data from unauthorized access. Because of sandboxing, you cannot directly browse the entire file system like you would on Mac OS, Windows, or Linux. You are limited to your app's designated container. This container has specific directories you can use. 2. Accessing your app's sandbox. Your app's sandbox is where you'll store all of your application's data. There are several directories within your sandbox, each intended for specific purposes. Here's how to get their paths. Explanation **** filemanager.default, this provides access to the system's file manager. *URLs, for in, this method retrieves an array of URLs for the specified directory. *document directory, this is the directory for storing user-created or user-importable data. Files in this directory are backed up to iCloud. *document directory, user-generated content and documents. Important, ensure user documents are in this directory for iCloud backup and iTunes file sharing to work as expected. *caches directory, this is for storing data that can be recreated if necessary. Files in this directory may be purged by the system when space is low. It is not backed up to iCloud. Good for downloaded content for streaming or temporary images. *caches directory, volatile data, download caches, and temporary files that can be regenerated. The system may delete files from this directory when space is low, so never store irreplaceable data here. Not backed up to iCloud. *temporary directory, a temporary directory. The system may clear this directory periodically. *application support directory, used to store data used by the application that should not be exposed to the user. Important, this directory is suitable for storing data that's necessary for the app's functionality but isn't directly user-generated. *userdomain mask, this specifies that you are looking for the directory within the user's domain. *paths first, the method returns an array, but usually only the first element is relevant, and it's guaranteed to be there. Example usage *. 3. Using filemanager. The filemanager class is the core class for working with files and directories. It provides methods for creating directories, deleting directories, creating files, deleting files, reading file contents, writing file contents, moving files, copying files, checking if a file or directory exists, getting file attributes, example creation date, modification date, size. Listing the contents of a directory. 4. Reading and writing files. Let's demonstrate reading and writing text files. Explanation *. Save text to file. Gets the documents directory. Creates a URL for the file by appending the file name to the documents directory URL. Uses try-text.write, to, atomically, encoding to write the text to the file. Atomically, true ensures that the entire file is written successfully, or nothing is written, preventing data corruption if the write process is interrupted. UTF-8 specifies the text encoding. Read text from file. Gets the documents directory. Creates a URL for the file. Uses try string, contents of, encoding to read the contents of the file into a string. Error handling is done using do-catch blocks. 5. Creating and deleting directories. Explanation create directory. Gets the documents directory. Creates a URL for the new directory. Uses filemanager.default.create directory, with intermediate directories attributes to create the directory. With intermediate directories, true creates any necessary parent directories if they don't exist. Attributes, nil uses the default directory attributes. Delete directory. Gets the documents directory. Creates a URL for the directory to delete. Uses filemanager.default.remove item, to delete the directory, or file. 6. Listing directory contents. Explanation *. List directory contents. Gets the documents directory. Creates a URL for the directory to list. Uses filemanager.default.contents of directory, @path to get an array of strings representing the names of the files and subdirectories in the directory. The @path parameter expects a string that is a file path, so we extract the path from the directory URL using directory URL.path. 7. Moving and copying files. Explanation move file. Gets the documents directory. Creates URLs for the source and destination files. Uses filemanager.default.move item, to move the file. Copy file. Gets the documents directory. Creates URLs for the source and destination files. Uses filemanager.default.copy item, to copy the file. 8. URL schemes for opening files in other apps, limited. iOS uses URL schemes to allow apps to communicate with each other, in a limited way. If an app registers a URL scheme for a specific file type, your app can use uiapplication.shared.open, URL, options, robot smiley, completion handler, nil, to try to open the file in that app. Example asterisk. Important notes asterisk. Asterisk reliance on other apps asterisk. This method completely depends on whether the user has installed an app that registers a URL scheme for the file type you're trying to open. Asterisk app discovery asterisk. You have to know the URL scheme that the other app uses, which is generally not public information. You often need to look up their documentation or reverse engineer their app. This is why this approach is limited. Asterisk sandbox boundary asterisk. You are still interacting with the file within your app's sandbox. You're just asking another app to view or edit the file. 9. Document providers / pickers, UI Document Picker View Controller. UI Document Picker View Controller allows your app to access files that are managed by other apps or stored in cloud services. It provides a user interface for selecting documents. Example asterisk. Explanation asterisk. 1. Import mobile core services asterisk. This framework provides the CUDA-PEPF and KUT type text constants, uniform type identifiers, that define the file types the document picker will filter. 2. Implement UI Document Picker Delegate asterisk. Your view controller must conform to the UI Document Picker Delegate protocol to handle document selection. 3. Create and present UI Document Picker View Controller asterisk. Asterisk document types, specifies the file types your app can handle. You can specify CUDA-PEPF, KUT type text, KUT type image, KUT type audio, KUT type movie, or a custom UTI. Asterisk in, .import, specifies that you want to import the document into your app's sandbox, copy it. You can also use .open to open the document in place, but you'll need to manage security scoped bookmarks for persistent access. Asterisk allows multiple selection equals false. This limits selection to one file. Set to true to allow multiple files. 4. Document picker, _did pick documents at asterisk. This delegate method is called when the user selects a document. Asterisk selected file URL asterisk. This is the URL of the selected file. Asterisk selected file URL. Start accessing security scoped resource, and selected file URL. Stop accessing security scoped resource, asterisk. These are crucial for accessing files outside your app's sandbox. Because these files are managed by other apps or are in cloud storage, you need to request access to them. The start accessing security scoped resource method returns true if access is granted, otherwise, it returns false. It's absolutely vital to call stop accessing security scoped resource when you are finished with the file to release the resource and avoid security issues. The resource needs to be accessed and then released. Asterisk read the file data asterisk use data, contents of, selected file URL, to read the file's contents. Asterisk handle the data asterisk save the data to your app's documents directory, or wherever you need to store it. 5. Document picker was cancelled, _*. This delegate method is called when the user cancels the document picker. Important considerations asterisk. Asterisk security scoped bookmarks asterisk. If you need persistent access to files picked with the document picker, you'll need to create a security scoped bookmark. A bookmark is a small data structure that stores the information needed to access a resource even if it's moved or renamed. This is more complex, and there are tutorials specifically on using security scoped bookmarks. Asterisk user experience asterisk. The user chooses which files your app can access, so provide a clear explanation of why your app needs to access those files. Asterisk file types asterisk. Properly specify the document types to provide a relevant and useful selection interface. 10. iCloud Drive integration, UI Document Browser View Controller. UI Document Browser View Controller provides a user interface for browsing, creating, and managing documents stored in iCloud Drive. It's more powerful than UI Document Picker View Controller for working with iCloud documents. Implementing UI Document Browser View Controller involves more setup, including enabling iCloud capabilities in your Xcode project. Enable the iCloud capability in the Signing and Capabilities tab. Make sure you have an iCloud container configured for your app. Setting ls supports opening documents in place in your info.plist file. Set the ls supports opening documents in place key to true. This allows your app to open and edit documents directly in iCloud Drive without creating a local copy. Implementing the delegate your app needs to implement the UI Document Browser View Controller delegate to handle document creation, import, and other events. Example, conceptual. 11. Code examples in Swift, recap. The code examples are already provided in the sections above. This section is a reminder to refer to those examples for specific implementations. 12. Error handling. Do catch blocks. Use do catch blocks to handle potential errors when working with files and directories. Try. If you don't need to know the specific error, use try to attempt an operation and get nil if it fails. Try. Only use try if you are absolutely certain that an operation will not fail. Otherwise, your app will crash. Avoid it in most cases. Check return values. Functions like create directory, delete directory, save text to file, etc., return bool values indicating success or failure. Always check these return values and handle failures gracefully. 13. Security considerations. Never store sensitive data in plain text. Encrypt sensitive data, passwords, API keys, etc., before storing it on disk. Use the keychain for storing credentials. Limit file access. Only grant your app the minimum necessary permissions. Input validation. Validate any data that your app reads from files to prevent vulnerabilities. Be careful with user-provided file names. Don't allow users to specify arbitrary file names, as this could lead to security issues like path traversal vulnerabilities. Sanitize file names before using them. Protect against data corruption. Use atomically, true when writing files to prevent data corruption if the write process is interrupted. Conclusion. While iOS restricts direct access to the entire file system, the filemanager class and related APIs provide robust tools for managing files and directories within your app's sandbox. By understanding iOS sandboxing and using these APIs carefully, you can build secure and reliable file management features into your iOS applications. Always prioritize security and error handling to protect your app and user data. And remember to use UI Document Picker View Controller and UI Document Browser View Controller for interaction with files outside the sandbox where appropriate. Good luck.